how do eigenvalues connect to stuff that you already know? Determinant, rank, and invertibility. So, in a certain sense, the determinant of A is determinant of Si minus A whenever S is equal to 0. True? And then we have that this stuff here is S, the product of S minus lambda i's. True? And then for S equal to 0, we get something that is this expression here. Because actually, from a sign perspective, you might also write like this one, IS, and then you got the right signs. We do not mess up with the signs. Okay, you get the point? Very obvious and immediate whenever considering A. So at this point, you remember that determinant of A connects with invertibility and rank. True? We remember that if I've got determinant of A equal to 0, can I have invertibility? Yes, no, I do not know. No, no, no. Because determinant of A equal to 0 means that the rank is going to be deficient. True? It's going to be smaller than n, with n the number of rows or columns. How much are we together on this part here, people? I hope we are very much together. Okay, and then the point is this one. Let's see, we do an exercise, and if we get the exercise right, I think that we can continue. I have x dot equal ax for which 0 is a marginally stable equilibrium. Tell me if A is invertible. Yes, no, I do not know. This is a classical question of the exam. Super classical question of the exam. And whenever I read this, I mean it's marginally stable and not convergent, okay? It's only marginally stable. Okay, people? I would like, yes. Is A invertible in this case? Yes. No, you do not know. What do you say? What do you say? I see no as a main option, and indeed it's no. The reasoning is this one. If the origin is just a marginally stable equilibrium and not convergent, it means that there are other equilibria around. True? True? Together? If there are other equilibria around 0, it means that we are going to have a subspace of equilibria. Linearity. True? If I've got that this is an equilibrium, also this has to be an equilibrium, also this has to be an equilibrium because of linearity. How much are we together, people? 1, 2, 3. Perfect. It means that the kernel of A is non-trivial. Question.
Could you also say that since it's marginally stable, you would assume that there has to be a pole in origin, and since there is a pole in origin, then you have a 0 eigenvalue.
And I am arriving there. I'm arriving there. It's better to say eigenvalue equal to 0 than pole, because pole and eigenvalues are two different things. They are similar but different. We are going to arrive there. Anyway, there's the kernel that is non-trivial. Kernel non-trivial means that 0 is an eigenvalue. 0 is an eigenvalue means that this one is equal to 0, means that this one is not invertible. Are we together, people? Excellent. How much are we together, people? Very much, not at all, kind of. Okay. And I think for this module, we are there.